I paid £266.99 for this broken, and I'll say broken, MacBook Pro A2289. This is a 2020 model and apparently it's got no power. However, when I attempted to turn it on just for the initial visual inspection, it turns on. Weirdly. It does some weird thing with the charger, where the charger seems to flicker. I've got these chargers in the house which have got lights on them, and it seems to flicker with the charger plugged in, which is really weird. And when I did get it to boot up, it showed a charging symbol, but the battery was showing 0%. And I also tried to get into safe mode or recovery mode, and I couldn't get in. It got to the boot stage where I could choose a Wi-Fi network, and then it just went to a blank screen. So something weird's going on, but at the moment it does seem as though it's partially working. So I thought it'd make an interesting video, but if you are new to the channel and you like this type of content, I would really appreciate it if you hit subscribe and turn on the bell notifications. That way you don't miss any future videos. And if you do want to support me in any way, if you want to help me to continue buying stuff like this, then you can head over to Twitch, become a Twitch Prime subscriber by linking an Amazon Prime account to Twitch, and then subscribing absolutely free. It doesn't cost you a penny, but it does massively help me out. But with that being said, let's get into this repair. Right we are. So here's the listing then. It's not going to show that I've bought this because I was logged into my partner's laptop and I ended up buying it on her account. But it's one of them things, you know, it doesn't really matter. It's this laptop anyway. So we can see we've got MacBook Pro 2289 and it says device does not power on, so listed as parts only. Screen looks in good cosmetic condition. Cannot test because of no power. Find My iCloud is off. So, or Find My iDevice, whatever it's called. There are a couple of dinks according to the pictures. And as you can see there, there's one there and there's also a little one just there. But other than that, it's in fairly good condition. I have bought off this seller quite a lot. I have actually bought, in the past couple of days, I've bought 4 items from this seller. But yeah, £266.99, and yeah, I'm kind of happy so far. And let me show you why. So this is the laptop. I'm not sure why it said silver on it, and I'm also not sure why it said no power, because if we take a look, and as you'll probably have seen by the thumbnail, it does attempt to boot. And in fact, I have actually successfully got it to boot without doing anything to this at all. So you can see there we've got a battery symbol. That's just indicating the battery is dead. And if we plug it in, it would appear as though the USB ammeter is just resetting. So it seems to me as though the charger's detecting some sort of an issue. So I'm wondering if this is kind of liquid damage, you know, really minor liquid damage where there's a partial short on something. But as you can see, I'm going to have to blur that screen out. But as you can see, it is turning on. It's coming up that there's no battery. Or, well, it's coming up that the battery's at 0%. But, oh, it's just gone off. All right then, never mind. Whatever. Okay, so, yeah, there is an issue. But it's not quite as described. So, let's get this thing apart. Alright, I can immediately see some corrosion. We've probably got some corrosion around the battery circuit somewhere because it's not detecting a battery by the look of it. Which is rather strange because it does power on, and as far as I'm aware these won't power on without a battery. But the battery looks in good condition. So we've got some corrosion here. We've got some here. A little bit here maybe, I think. Sorry if my big head's in the way. And yeah, I mean, overall, this looks in really, really good condition, actually. So it doesn't look too bad. But I'm going to get the board out. The first thing I'm going to do is, well, disconnect the battery, because we don't want to cause anything to get damaged. Always try and disconnect the battery by unscrewing this screw first. And the reason for that is because that way then you're completely isolating it from the main power rails. This here I believe is just for sense lines and stuff like that, so I don't think it carries any current. Or any real current that could cause any damage. It would carry current, of course. Alright, so battery disconnected. Now I'm going to disassemble the laptop and take out the board. Trying to remember where the screws go, but I'll fast forward through this. If you want a proper teardown of this, I recommend just searching for an iFixit teardown. They do some great teardowns. And iFixit, if you're there, if you're listening, if you're watching, if you're peeking on me, sponsor me. sponsor me. Give me some of your iFixit money. No, on a serious note, check out iFixit for a teardown guide. It's really recommended. And there we go. Alright, so the board's out. That's the first time I've ever taken one of these apart, and there are way too many ribbons. Not as bad as the PS5 screws, but way too many ribbons. I've got to remember how to put that thing back together. That's going to be fun. Not. Alright, let's pop under the microscope with this and we'll see what is going on. Alright, so the first bit of corrosion I'm seeing is just here. And I'm not sure what any of this does, but I'm going to try and find a schematic. So we've got some corrosion around here. So basically, just to explain what corrosion is, it's a chemical reaction when water and electrics meet. So, you know, when water meets PCB, you get this stuff, in simplified terms. So yeah, that's the result of liquid damage. I'll say water, I mean liquid damage in general. But basically, corrosion is conductive. So if you've got corrosion, even if it's not blowing a component, then it can cause shorts on different circuits and things like that. Like for example, this, it could have a short here if you know, if these two parts are conducting. You know, the cap itself, if the input side of the cap and ground are touching because of corrosion, that can cause an issue. So I'm just going to scan around the board. I mean, there's quite a bit of liquid damage here. It's quite considerable in this area. I will find out what all of this does. I just want to try and figure out where all of the corrosion actually is. I don't think it's too major. CD3217, that's the charging IC, that looks okay. There should be two of those on this board. I've got some more liquid damage here. A little bit more there. Alright, so not too much on that side. Let's have a look on the other side. Alright, we've got some corrosion around here. This Intersil ISL 9240. So that's a fairly common area to become damaged. We're going to have a problem there on that 9240, and I do have some donor boards I can take one of those from. That could be causing issues with the battery. I think most of this is just going to need a clean up and maybe the odd component here and there replacing. There's the other CD3217. So yep, two of those on the board. I'm glad they're not damaged because I've actually had to buy some. I'm waiting for them to be delivered. Alright, let's start off with this area here. I mean, this looks really, really bad. You know, this one particular cap here, that does look pretty bad. However, I don't think the corrosion has found its way underneath the chip. The chip is a BGA chip, so it's a bit more difficult to fix than a normal chip. So I'm going to find a board number for this, actually. And I'm going to find a schematic. I can't tell you exactly where to get the schematics from, but Google is your best friend. And all you need to do is type in the board number and then type schematic at the end. Alright, so I've got the board view here. And I'm using the wonderful Paul Daniels Flex Board View software. Absolutely fantastic piece of software. You can get a free version, this is the paid version though. We've got some corrosion around this area here. So this resistor here are 7021, C7021. Would you look at that? Charger CSIP. So that's a charge line. Oh, that's a charging line. Interesting. So that could be literally the sole cause of the issue. So this is where it's linked. It's linked to the resistor, the cap, and this small cap here. The one good thing about Paul Daniels' software is if we click on one of the items, we can click on PDF and it'll take me straight to it. So battery charger ISL 9240 U7000. So I want C7021 on the PDF. R7021 is at 1 ohm. 0.047 microfarad. Okay, well, we can probably pull these components off a different board, assuming I've got one. So this area here, right off the bat, just by doing a visual inspection, just by looking at the board, it's giving me a clue as to what's wrong. So when I attempt to turn this on, it comes up with the battery symbol, but then when it does actually turn on, it's not recognising the battery, or rather it's recognising that it's at 0%. So that's telling me that it's not charging the battery at all. So that's obviously going to be caused by something on the charge line. So let's get that area taken care of. I'll be using a donor board for this just because it's a lot easier. But basically the good thing about the schematics is you can find the component values and things like that, and then if you don't have a donor board, you can actually get them. We're not obviously meant to have the schematics, but you know, they fall off the back of lorries. And when they fall off the back of lorries, no one really needs them. They get run over by trucks and cars and motorbikes, and then someone walks along, finds it, and then we can use it. So yeah, thank you to that person. Anyway, like I said, this is going to give us an indication as to what's happening with it. So if I just get this lined up here, what I'm going to do is I'm going to start replacing these. So one thing I don't do is clean up the area before I actually work on it, or rather before I've determined where the issues lay, because just like a crime scene, you don't want to get rid of the evidence before you've logged it. So I'm taking mental notes, but I'm also checking with the schematic and things like that and finding out exactly what's what and figuring out where the issues are before I get rid of that corrosion and before I actually do any work to the board, because otherwise I'm just going to be lost. I'm not going to know where to look. So now that I know that this area is going to be causing a problem, let's just clean it up. So I'll use a bit of isopropyl alcohol to get rid of some of this corrosion, and then I can see the components a little bit better, and that will allow me to test them as well. And I am completely aware as well that there's corrosion on the other side of the board directly below here, which is the corrosion we saw when we first took the base off. So I don't want to get rid of that evidence until I actually start to take care of it. So I am going to be mindful of that. But yeah, as you can see, the entire area which was damaged was the charger line. So what I'll do then, before I do anything, I'm just going to test these components, see if we've got any shorts on the line, and see if we have any issues with that resistor. You know, that resistor might be blown. That could be what's causing it. It might not be allowing current to pass. So let's just test those. So if you look in the top right corner, you'll see the multimeters on the screen, and I'm in resistance mode right now. So you can see it says overload. That's because I'm not connected to anything. So I'm going to check the resistor first and just see if we've got an issue with that. I don't want to waste time replacing components I don't need to, but that resistor, I mean, to be fair, probably needs replacing anyway. But let's just see if we can get a reading on this resistor. And it's coming up overload. Oh, okay, well, it's just knocked off. Ha! It's just pinged, so that's got to be replaced. Hello. Yeah, so that's definitely bamboozled. It pinged off just by touching it. And it doesn't look like we're short to ground on there. So testing from one side of that cap to the other in resistance mode. You know, we're getting all sorts of thousands of ohms. It's definitely not short. So we've definitely not got an issue with a short to ground. I think the issue here is probably mainly going to be the fact that we're not getting any connection on that resistor. So I'm going to have to try and fix this area up, you know, the pad and things. Try and restore that pad. I don't really want to run jumper wires if I don't have to. I may need to remove a couple more components just to Oh no, that pad looks like it might be gone. Yeah, that pad may be gone. So it might need a jumper wire. Alright, let me just check and see if I can find any kind of continuity. So my meter's in beep mode. And no, not giving any. Oh yeah, okay, so that side is connected to the capacitor. So here's what I'm going to do. I'm going to find that test pad, and I believe it's this one just here. Let's just see if I get any kind of continuity when I beep that out. No, so it looks like the pad is completely gone. Alright, well that's fine. I can still work with that. So what we would do in this situation then is we would run a jumper wire. So a jumper wire just allows us to connect the trace back to where it's meant to go to, because the pad's missing, which means I can't solder a new resistor to that area, right? So we run a jumper wire because we want to reconnect it. So that substance I've just added is called flux, and that's going to help solder to flow. So I need to tin the pad before I can solder to it. There we go. So it doesn't matter if I've got solder on one of the other pads, that's absolutely fine. But I'm actually going to just remove another component. I'm going to remove that other burnt cap. If I'm going to work in the area, I may as well just remove that other one. So I've got my hot air set at 440 degrees Celsius at 40% airflow. And I'm actually going to add some flux around the ISL chip. It's a BGA, I don't want to end up causing issues with the solder pads and floating the chip. So if I add some flux, that will prevent the pads underneath the BGA from oxidising. There we go. And now I can run my jumper wire. Actually, let's tin the other pads first. Let's not run a jumper wire till we've tinned the rest of the pads. Let's just clean that up a second. I can just about see a wire there, a little nub, but I don't know if it's going to be going to the area where I need it to go to. So what I'm going to do, rather than risking that being a completely different track altogether, I'm just going to conformal coat that, because I don't want to chance it, I don't want to short it out, especially being a battery line. If that was, let's say for example, a CPU line that's underneath there, you know, we may have a CPU sensor line or something like that, and you end up sending 12 volts coming from the battery, then yeah, you're in trouble. So just add a bit of conformal coating to it just to protect the area before I add a jumper wire. Risk mitigation is what it is all about when it comes to repairs. Then I'll just cure that using a UV light. So that stuff I've just used is called conformal coating or solder mask, whatever you want to call it, and that just basically re-insulates the area. There we go, and that's hardened. I used a little bit of warm air to assist in the curing process. It just cures a lot harder and a lot quicker. That is not what she said. Not to me anyway. Alright, anyway, let's run this jumper wire that we so long for, shall we? I'll just tack that there temporarily. I do realise I've got to use a little bit of flux. Would you look at that? It's actually, I had some conformal coating left on the tweezers. It's just added it in the perfect place. I might as well add a little bit more actually, just to hold it down. And then I'll use flux and touch it up at the end. So I'll add a bit there. So I'm going to wrap this around a little bit just to get it into the position I need it. But I might as well cure that while I'm here. There we go. Right, so I'll sort that solder joint out at the end. I realise it's not a good joint at all. The good thing about this wire as well is it's 0.1mm, but the good thing about this wire is the fact that it's enamelled, which means that I can wrap it around, it's not going to short out on anything. Okie dokie, that should be good. Let's just sort this joint out. That's better. Alright, and now I'm going to grab a couple of components off a donor board. Alright, so these resistors are the same. So this is a 820-01949 board, but it's the same circuit. Let's drop that there a second. I'm going to knock my airflow right the way down to 1% here. And this is not going to look pretty when it's done. It's certainly not going to win the beauty pageant. Ah, damn it. That weren't meant to happen. Alright, that looks connected. Let's just give this area a bit of a clean. Okay, that should, the key word there is should, but that should be good enough to work. Alright, so as you'll see there, I used an 820-01949 board there. It's 2251 or 2279 or something like that. So yeah, that was my donor board which I used, and hopefully this is going to work now. We'll see. We will see. Let's just get it put back inside the housing. I won't screw it back together. I'll just give it a test. Get off there, jumper wire. Thank you. So a quick and dirty test I think is going to be to just connect up the battery and just see if it takes a charge, you know, on the ammeter. That's going to be the quick and easy method, I think. Okie doke. Just screwing in the battery and connecting up the battery ribbon. And it's time for the moment of truth. Is she going to work? Is it going to take a charge? Or are we going to have to go back to the drawing board? Please work. 5 volts. 20 volts, that looks like it's taking a charge to me. 0.4 amps, 1 amp. Apple logo, 1 amp. Come on. Okay, it's still showing a 0% right now. but the charger's not flickering. So I'm going to leave this for a minute, see if it turns itself off or anything like that. And, well, hopefully the battery kicks into life. It might have completely killed off the battery though. It's staying on so far. 1 amp is definitely not enough to be taking a charge, that's for certain. But it might be that the battery is just completely dead. Okay, it's starting to increase. Come on. Come on. You can do it, little MacBook. 1.5 amps. I'm looking for around about 3 amps at 20 volts. 1.7. 1.9. That looks to me like it's taking a charge. I'm going to give this 10 minutes. I'm going to go and get a cup of coffee, because that appears to be charging. So it's been about 5 minutes. I've grabbed myself a cup of coffee. Currently drawing 3 amps of current, which is fantastic. And yes, indeed, we are now on 3% battery. I'm going to cover up this old owner's details. Whoops. But we now have battery. Fantastic. This is working. I need to do some more tests. For some reason, the touch bar isn't on. I'm not sure why. I'm going to shut that down. What I'll do, I'm going to reassemble this fully. I think some laptops you have to be logged in for the touch bar to work. I don't know. But we'll try it in a minute. For now, it's not a big issue. I'm going to leave that charging while I reassemble this. Fully reassembled and back together. Let's do the moment of truth. Is it going to power on? Let's just leave it to try and yeah, there you go. Powers on its own, which means that the screen sensor is working fine. I did see that the current had dropped down to 2.4 amps. That's perfectly normal, by the way, for current to drop. And the reason for that is because it's kind of like supply and demand. It's going to request the current that it needs, not a set amount constantly. So it starts off at like 3 amps and then it'll drop down to you know, a lower amount based on how much percentage is in the battery, essentially. And sweet, it's automatically gone in to reset the password. Awesome. I'll take that. Erase Mac. And that is now being erased. Battery is 19%. And yes, it is indeed detecting when it's unplugged. Let's check it on the other port, make sure that works. Yeah. Fantastic. Absolutely fantastic. I do still need to do some tests. I do have a set process on what I'll do for testing. So what I'll do with this now is I'll erase it, or rather I'll let this run. I'll let it wipe, and then I'll reinstall macOS, update it to macOS Ventura. It's not got, I don't think it's got iCloud on it, or at least it shouldn't do. And if it has, I'm not going to be happy. But yeah, what I'll do is I'll erase it, I'll put Ventura on it, and then once Ventura is installed, I'll test the camera, the keyboard, the trackpad, Wi-Fi, sound, screen brightness, and all of that kind of stuff. Make sure that it automatically adjusts to brightness and things like that. And then yeah, this will be on to be sold, and someone can enjoy this. I've got a MacBook, so I don't need one. So I'm going to sell this. I should get around about £500 or £600 for it. I think that's about the going rate for the 2289. But yeah, I'm really, really happy. So glad that I could get it working. It took me, including disassembly and reassembly, about an hour and 20 minutes to actually do this. Got really lucky. All of the damage I could see. Had to replace that resistor and capacitor, and obviously the one on the front of the board as well as running the jumper wire, and then just a basic clean up of the corrosion, and yeah, it seems to be working fine. So that's going to be it for this video. Thank you very much for watching. If you do have any comments or questions, leave them down in the comment section down below. If you do want to organise a repair, there'll be a link in the video description. You can book in a repair, or you can get in touch if you've got a question about a repair as well. If you do want to support me, you can head over to Twitch and become a Twitch Prime subscriber by linking an Amazon Prime account to Twitch and then subscribing absolutely free. As I said earlier on, it doesn't cost anything to do, but it does massively, massively help me out. But with that being said, that's going to be it for now. Thank you very much for watching, and until next time, I'll see you later. Bye for now.